Imagine a computer that doesn't just run on electricity and code, but also on life itself. Think about a machine that uses real, living human brain cells to think and learn. This is not a story from a science fiction movie. This is a real technology happening today. On September 20th, 2025, an Australian company named Cortical Labs has created something truly amazing called the CL1. It is the world's first biological computer that you can buy or even rent. This machine mixes tiny parts of a human brain called neurons with a silicon computer chip. It creates a powerful new tool for scientists who want to understand the most complex object we know of, the human brain. This is a huge step forward in how we study our own minds. What makes this device so special is its unique design. It is a bridge between the biological world of our bodies and the digital world of our computers. For many years, scientists have tried to copy the brain using only software and powerful machines, but the brain is incredibly complicated, and our best computers still struggle to act just like it. The CL1 takes a different path. Instead of just copying the brain, it uses the real thing. By placing living neurons directly onto a chip, scientists can watch how they connect, communicate, and learn in real time. This gives us a front-row seat to the fundamental processes of thought and memory. It is a bold new way to explore the mysteries of consciousness. This new technology is built on an earlier famous experiment. You may have heard of a project called DishBrain. In that experiment, scientists taught a small collection of brain cells in a dish to play a simple video game called Pong. The cells learned how to move a paddle on the screen to hit a ball. This showed that even a small group of neurons could learn and respond to its environment. The new CL1 device is a much more advanced version of that idea. It has more channels to send and receive information, and it works much faster. It is a powerful platform that moves beyond simple games and allows for serious scientific research into how our brains work. The goal here is not to create a thinking machine that will take over the world. The purpose is much more important and helpful. It's about understanding ourselves. How does a memory form? What goes wrong in the brain when someone has a disease like epilepsy or Alzheimer's? How can we develop better medicines to treat these conditions? These are the big questions that the CL1 can help us answer. By giving scientists a new window into the living, learning brain, we open up possibilities that we could only dream of a few years ago. This is more than just a new computer. It is a new way to explore the very essence of what makes us human. So how do you build a computer that uses real human brain cells? The process is both delicate and brilliant. It starts with adult human cells, often taken from skin. These cells are then reprogrammed in a laboratory. Scientists use special techniques to turn them back into stem cells. These are powerful cells that can become any type of cell in the body. In this case, they are guided to become neurons, which are the main cells of the brain. About 800,000 of these newly grown neurons are then carefully placed onto a silicon chip. This chip is designed with many tiny electrodes that can both listen to the cells and talk to them using small electrical signals. Once the brain cells are on the chip, they need a safe and healthy place to live. The CL1 device has a sophisticated life support system built right into it. This system acts like a miniature body for the neurons. It constantly supplies them with a special liquid full of nutrients like sugars and salts, which they need to survive and stay active. The system also carefully controls the temperature and environment inside the device, keeping it perfect for the cells. This is what allows the neurons to live for months, forming connections with each other and creating a small living neural network. It's a tiny, self-contained world designed to keep a small piece of a brain alive and functioning. The magic happens when this biological network is connected to the digital world. The electrodes on the silicon chip are the key. They can send electrical pulses to stimulate the neurons, which is like giving them information. The electrodes can also record the electrical signals that the neurons send back and forth to each other. This is how the neurons communicate. Because the signals are electric, they are incredibly fast, happening in less than 1,000th of a second. This allows scientists to send simple code as an input, see how the neural network processes it, and then read the output. The CL1 becomes a living laboratory for studying learning at its most basic level. This combination of living tissue and electronic hardware is sometimes called wetware. It is a new frontier in computing. Unlike traditional computers that follow strict rules, this biological computer can learn and adapt on its own. It can change the connections between its neurons based on the information it receives, just like our brains do when we learn something new. The CL1 is therefore not just a fast calculator. It is a dynamic system that offers a glimpse into the biological principles of intelligence. By building this system, we are not just making a new tool, we are learning to speak the brain's own electrical language. For a long time, technology this advanced was only available in a few elite research labs, but Cortical Labs is changing that. They have made the CL1 device available to the wider scientific community in two different ways. For large institutions or well-funded research teams, it is possible to purchase a full CL1 unit. The cost is around $35,000. This gives them their own biological computer to use in their laboratory whenever they want. This option is perfect for long-term studies or for developing new experiments that require constant access to the hardware. It puts the power of wetware computing directly into the hands of the researchers who need it most. However, not every scientist or small lab can afford such a high price. To solve this problem, Cortical Labs has created a very clever solution. They offer a service where you can rent access to a CL1 device remotely over the internet. This is called Wetware as a Service. For about $300 a week, a price less than a new video game console, a researcher from anywhere in the world can connect to one of the devices at Cortical Labs. They can run their experiments, send data to the neurons, and collect the results without ever leaving their own office. This makes this powerful technology much more accessible and affordable for a broader range of scientists. This rental model is a game changer for scientific research. It means that a small university, a biotech startup, or even an individual researcher with a great idea can now work with living human neurons. They don't need to build their own expensive lab or learn how to grow and maintain the cells themselves. They can simply log into the platform and start their experiments right away. This will speed up the pace of discovery. More people with different ideas can test their theories on how the brain works. It democratizes access to a technology that could lead to major breakthroughs in medicine and artificial intelligence. Of course, working with human cells comes with important rules. If a lab buys a CL1 unit and wants to use its own new line of cells, they must get ethical approval first. This ensures that the cells are sourced and used responsibly. The device must also be operated within a proper laboratory environment to ensure it is handled correctly and safely. These rules are in place to make sure that this powerful technology is used for good, pushing the boundaries of science while respecting ethical standards. This careful approach ensures that we can explore the brain's mysteries in a way that is both responsible and revolutionary. So what can scientists actually do with a biological computer like the CL1? The possibilities are vast and exciting, touching many different fields of study. One of the most important applications is in medicine, especially for studying brain disorders. Scientists can use cells from patients with conditions like epilepsy or Alzheimer's disease to grow a small neural network on a chip. This creates a disease in a dish model. They can then watch how these specific neurons behave differently from healthy ones. They can also test new drugs on these cells to see if a medicine can fix the problem without ever needing to test on a human or animal. In fact, this technology has already shown its potential. In one important study, researchers used the CL1 system to model epilepsy. Epilepsy is a condition where the brain has uncontrolled electrical storms causing seizures. The scientists created a neural culture that showed this kind of chaotic activity. Then, they used the device to stimulate the cells in a specific way. They found that they could restore the normal learning function in the cells, essentially calming the electrical storm in the dish. This is a remarkable step. It shows that we can use this technology not just to study a disease, but to find and test potential ways to treat it. Beyond medicine, the CL1 is also a powerful tool for developing and testing artificial intelligence, or AI. Today's AI systems are very good at specific tasks, but they use huge amounts of electricity. The human brain, by contrast, is incredibly efficient. It can perform amazing tasks using about the same amount of power as a dim light bulb. The CL1, with its living neurons, also uses very little power. By studying how these biological networks compute and learn, AI developers can get new ideas for building more efficient and powerful AI systems. It is learning from nature's best computer to build better technology for our future. Ultimately, the arrival of the CL1 marks the beginning of a new era in neuroscience. For centuries, the brain has been a black box. We could see what goes in and what comes out, but the processes inside were a deep mystery. Now we have a window into that box. We can directly interact with the building blocks of thought and learning. As the respected neuroscientist Carl Friston said, the CL1 is a remarkable achievement that allows us to test our biggest ideas about the brain with real neurons. This is more than just an exciting new gadget. It's a fundamental shift in our ability to ask and answer the deepest questions about who we are